In this video, we're going to look at a pH curve for the titration we just did. So we need all of our calculations. So if I go back to where we had all acid, no base, 0 milliliters of base, pH of 0.699, 10 milliliters of base, pH of 0.824. 20 milliliters of base, pH of 0.942. 50 milliliters of base, pH of 1.300. 100 milliliters of base, pH of 7, because we're at the equivalence point. 150 milliliters of base, you can't see this, pH of 12.398. And then 200 milliliters of base, we've got a pH of 12.602. So now what we're going to do is we are going to enter our data into Excel. So I've got 0 milliliters of base, 10, 20, 50, 100, 150, and 200. And then our pH at each of those, pH at 0 was 0.699, pH at 10 was 0.824, pH at 20 was 0.942, pH at 50 was 1.300, pH at 100, equivalence point, was 7, pH of, obviously Excel does not like sig figs, pH at 150 milliliters was 12.398, pH at 200 milliliters was 12.602. Okay, so now what we're going to do is we are going to graph these. Okay, so what I'm doing is I'm going to highlight, whoops, I'm going to highlight all of this. I'm going to go to Insert. I think I want to scatter plot. Let me do this. Okay, so now I could go ahead and I'm going to show you how to do this. So if you don't know how to do it, you know. No, I don't want that. All right, so I want to title this. This would be titration of nitric acid with sodium hydroxide. I don't know if this will let me. Yeah, I'm not going to worry about that. Okay. The left is going to be pH. pH has no units. The bottom is going to be volume of sodium hydroxide added, and that was in milliliters. Okay, so I would really like, and I forget how to do this, so I've got to go back and look. Okay, so I want you to be able to see what the curve actually looks like. I'm going to go back to scatter, and then I want to select this smooth line. Okay, so this is what we're looking at. I'm going to make it bigger so you can see. Okay, so this is a strong acid, strong base titration. I want to change it just a little bit, so I don't really like how this looks, and I don't like that you're having to listen to me talk, so I'm going to stop for just a minute. Okay, so there's several things that we want to notice here, and then I'm going to sketch a really quick graph of what it's more likely to look like in a textbook or something like that. Okay, so the first thing we want to notice, I need my pen back. Okay, here it is you know, this is where we haven't added enough base and, you know, the acid is still predominating. What you want to do when you look at a titration curve is you want to look at this really sharp increase in pH. And in most of the textbooks, at least for strong, it's much more vertical than it is here. But you're still looking for, you know, this really sharp increase in pH, where the slope is, you know, kind of almost vertical. Here it's not, but that's okay. Anyway, what you're doing is you want to look at the center of this. And for a strong, and this is going to always represent the equivalence point. Okay, so now if you were designing a titration and you were trying to pick an indicator, you would want an indicator that was going to change color really close to the equivalence point. Change color to pH really close to the equivalence point. And in your textbook, there's a table, which I'll show you a little bit later, but which will help you choose that. Okay, so if you look at this and we go over, that's at a pH of 7. So for a strong acid, strong base titration, the equivalence point is going to occur at 7. So you want an indicator that's going to change color really close to a pH of 7. Now let's say that we had done it the other way. Let's say we had started with sodium hydroxide and titrated it with nitric acid. So let's say this were sodium hydroxide and this were nitric acid. Whoops. Okay. Now, instead of starting at a low pH, we would be starting at a high pH. And that pH wouldn't change much, and then all of a sudden it would drop and then level off. So this would show you, this part of the curve would show you when your base is predominating. This would show you when you have excess acid. Just like this part of the curve up here was showing when you had excess base. You would look at the really, the part where the slope is very steep, and you'd look at the middle of that, and that would tell you that the pH of the equivalence point at the equivalence point was 7. So strong acids and strong base titrations are going to look just like each other. It's just you're going to have a different starting point and a different ending point. Okay, this is a diagram from your textbook where we've got strong acid, strong base titration. So this is like the one that we actually did the calculations for. So this part is where the strong acid is predominating. You can see that here. And then this is the really sharp rise in pH. And so to find our equivalence point, we look at the middle of that, which would be here, pH of 7. So I know that this is a strong, strong. Whoops, sorry, didn't mean to do that. Went the wrong way. All right, here we are, back where I want to be. Okay, so this is strong, strong, pH of 7. Here is where I have equal amounts, right here, of acid and base. And then after this point, the base is going to predominate until the base totally overcomes the acid. So what we're looking at is you want to pick an indicator which is going to change color really close to this equivalence point to indicate the end point when your titration is finished.